Good afternoon. Welcome to PCI's webinar series. Today's presentation is Digital Precast, Beginning to End Workflows for Precast Operations, and is sponsored by ALLPLAN. My name is Royce Covington, Manager of Member Services at PCI, and I'll be your moderator for this session. Before I turn the controls over to our presenters today, I have a few introductory items to note. Earlier today, we sent an email to all registered attendees with a handout of today's presentation. The handout is available now and can be found in the Handouts pane located near the bottom of the GoToWebinar toolbox. If you cannot download the handout, please email PCI Marketing at marketing@pci.org as shown on your screen. Note that all attendee lines are muted. The GoToWebinar toolbox has an area for you to raise your hand. If you raise your hand, you will receive a private chat message from me. If you have a question, type it into the questions pane, where I'll be keeping track of them to read during the Q&A period. PCI is a registered provider of AIA CES, but this presentation is non-CEU and does not contain content that is endorsed by AIA. Any questions about the content of this webinar should be directed to PCI. Program content does not constitute approval by PCI, nor does it necessarily reflect the views or positions of PCI or those of their respective officers, directors, members, or employees. Questions related to specific products or publications will be addressed at the end of the presentation. Our presenters today are David Lockery, Business Development Manager at ALLPLAN, and Frank Holtz, Senior Technical Consultant at ALLPLAN. We also have a guest speaker joining us. Paul Waldner is the Director of Conceptual Design and Development at Taracon Precast in Minnesota. He will be speaking on the topic of digital precast fabrication workflows and what Taracon is doing to streamline and optimize its work. I'll now turn the controls over to David to begin our presentation.
Thank you, Royce, for your introductions. So, Paul, hello. Thank you for joining us today. Before we talk about Taracon's dive into digital, let me ask, how did you manage projects before starting this digital transition?
Certainly, David. I appreciate the opportunity to chat about our digital drive at Taracon. We are to a large extent still utilizing multiple weak link software solutions. These systems have weak single-LAN ties to actual production processes. For production scheduling and coordination, we use PDF documents and web-based database systems consisting of patched, out-of-the-box software solutions that are self-coded to specific user requirements, a zero-logic system. This system is only as good and accurate as the guys manipulating the data inside of it. The system does not react to prompt design changes and has zero opportunity to interact with the project models themselves. It also lacks the power to tie production and QA processes to each other's. This is critical for streamlined workflows and harmonized production process flows on the MES side. We find it very difficult and time-consuming to execute day-to-day cycle tasks, let alone driving Sigma 6 process flows that are intended to continuously and logically improve business processes. As for managing raw materials, yarding, and actual precast element logistics, we are still using digital pencil and paper methodology. The reason we have mainly stuck to this is because there are no solutions or consistent data management systems available for us that grant us the flexibility to manage these demanding assignments, while at the same time giving us the freedom and awareness to complete the work in an efficient and transparent manner. This is a problem we experience across all spectrums of the business, be it machine controls, human-aided process cycles, forecast changes in weather, site conditions, and unforeseen production hiccups. At the same level, we also see ourselves passing metadata through various CAD systems to get it dumbed down to where we need it for CAM setups. So, coming from all this, we've decided to embark in a journey that will free us from all these constraints. Some of them we are working on, and others are a bit more of a challenge.
So a very siloed workflow at present. So with that, then why are we moving to an all digital fabrication workflow?
There are multiple reasons on why we are pushing for digital solutions. To keep this simple, we will list 3 items and iterate on them, each for a little bit. So the points are transparency, metadata, and training or visualization purposes. For one, and the first and the most important is transparency or insights. We feel that there should be no questions relating to anything that has connection to the design or the make of the project, be it material, processes, quality checks, reports, element parameters, material status, or even machine calibrations. Anything that has any involvement in the build itself should be clearly transparent. The working party on any specific tasks needs to be able to make decisions right on the spot, and the system shall allow the user to reach out to not only his working peers for answers, but also the broader build and retrieve data that surrounds the detail that he or she is working on. Another reason, as discussed earlier, is the push and changes metadata. We need more accurate data sets. Accurate data that we can use for direct machine control, that has material parameters associated that allow us to pull the files for CAM processing directly from a single source of truth. That way the materials and geometry are fully defined and always up to date. At that same level, we have a human element, which is the work and structure side of things, which we look at as MES. And typically that's referred to as machine control. But for us, we put the human element in the same bucket because, in a sense, humans are executing work as per a given set of instructions or a shop ticket. Now, that is in many forms. It could be a PDF or a model on a tablet, whatever it may be. The system should be intelligent and allow checks and for the procedure of the operator, and actively empower them by placing the required information at their fingertips. This should give them freedom to pull information on a particular detail, track what needs to be done for the day, or simply check on ongoing process cycles. We need a solution that drives operators to further enhance our end product. A solution that logically tracks down parts of a process cycle that have been developed but are falling by the wayside because of organization and chaos of dealing with the everyday. So things that have basically become something that just gets done because it's got to get done. A transparent interface or management system also holds some benefits in scaling business. If we grow from 100 square foot production measure to 1,000 square foot a day production measures, there are more materials that need to run through each of the same processes. Because of this growth, we need to split up the processes departments and their corresponding data sets. If that data visualization or dashboard flexibility is configurable by the end user, the task of splitting the dataset visuals is easy and will always be accurate. The system then allows a lot more opportunity for predictable workflows, and new hires do not have to manage all the data, but instead just make effective use of it. So everyone has full control and full visibility of what it takes to get the job done right.
So we're talking about being able to consume the data efficiently after it's created, and then also being able to rapidly get it into the hands of the right people in a way that doesn't require a huge amount of training or specialization.
Exactly.
Okay. Do you have an example of a situation that kind of a workflow would help manage?
An example would be, here in point of time, a little difficult to come up with, but basically any human error that can occur, like attaching a set of labels to the wrong set of fabricated assemblies. If that, for example, did happen, the pre-planning module would automatically highlight and trigger the person in charge, or create an alert when the prefabrication team basically sets up the production materials required for the next production setup.
So we're talking automated quality control and quality assurance, process improvement, reducing human error.
Correct. With using a checks and balance system that's set up inside the system.
Okay. Beyond the human element, then, you have referred back to automated machine guidance and things. How does a digital workflow help drive automation and time savings?
With a digital workflow in place that has built-in logical QA and QC reflecting the production process directly, we can drive ever-increasing product accuracy, leading to less rework on the modeling side and the physical precast production. The digital workflow not only allows us to harness the power of the geometry in the model, but at the same time, it gives us the opportunity to create a digital twin by feeding and intelligently collecting data that drives continuous improvement. This directly relates to the speed and efficiency gained by utilizing technology. The more accurate our data goes into the MES system, be that human, MES, or machine control, the more machine learning we can build into our digital workflows. On another note, we need to look at the savings in time that come from increased understanding or visuals on the shop floor. If the party executing the work has the capability at their fingertips to access the full spectrum of data associated to the tests conducted, they can make critical decisions on the fly based on the technical info they are working with, not only the assignment that they're working on, which further reduces errors and creates streamlined workloads. The workload distribution then also directly has an impact on the speed at which work is executed. This same concept holds true for materials management. Humans make mistakes. That is inevitable in the real world. But if we can gain knowledge in advance on which materials are in demand and what we have available for consumption, that gives any workflow additional capacity because it allows for further pre-planning at full accuracy. This holds true for everything from sub-assemblies to the actual precast components that are supposed to be delivered to the job site. So performance is directly linked to insight.
So we're really talking about two applications for data here. One is process improvement. How do we better anticipate what a project will look like the next time a similar project comes along? And
Exactly.
the other is that moving beyond fabrication details that are basically the digital equivalent of ink on paper. There's data that can be used to drive machinery directly with little or no human input.
Correct.
Okay. What obstacles are there to such a workflow? Specifically, a lot of this is software-based. Where are those platforms and tools still falling short?
The largest thing we struggle with is data interoperability. We face major issues in not being able to properly translate data from one system to the next. In fact, for some of the processes we have in place today, we end up transferring the data through 4 software platforms before we get it to the point where it's actually machinable. Granted, there are ways to work around this problem and the speed consumed and the time it consumed when doing it, but the matter of the fact still is that because of the broken up process, they need to be reviewed by humans. Every software solution converts various sets of geometry into slightly different textiles that alter the functions anticipated by the original designer. Working with multiple engineering firms, as in our case, poses a major challenge for us. Because at any given time, we are dealing with models that vary greatly in design procedure and thus in the export coming from that particular conversion. This creates a data structure that is made up of multiple silos and silo types, forcing us to review all the data as it is being processed, which is time consuming. With that said, it brings us to another point that we are forced to live by. Since each project has its own silo, not only in raw production data, but also in issues detected while producing the project. this creates a Sigma 6 principle that is totally dependent on human intervention. And because the humans are burdened with this overload that gets thrown at them, it slows down the process of total enterprise improvement to a crawling pace, and some opportunities for improvement are totally ignored at this point.
So really, we're talking about a standardization issue and a siloed data problem, and they're pretty much two halves of the same coin. A lot of this data sharing is manual processes, as you note, and that causes error. It causes us to drop opportunities that should be low-hanging fruit.
Correct.
Okay. Any thoughts on how you'd like to see these shortcomings solved?
Summing up everything we've talked about, there are several things we need to focus on. Step number one towards a viable solution is a standardized data format. We need a common data file type structure to work away from, preferably IFC4 or step file that supports PMI and model-based definitions. This will allow for solid decision making. The next step here is an information exchange system that communicates with blockchain data transfer so that it is 100% reliable and complete step for step. So we have a single silo that will act as a technical info manager, and then we have a separate silo for each project that stores the information per each given project. The technical manager then pulls and organizes the processes and pushes back the information per each given step to optimize performance and guarantee that everything is always up to date with the latest defined standard, including workflows, checks, reviews, transfers, and process integration that all need to be floating, synced, and accessible so that other parties can easily integrate and adjust as required to the system. So ease of use is critical here, and it always plays a role in scalability. The model silo needs to be structured so that any information like PMI and special parameters can be extracted to the desire of the user to create full visibility into the whole model when desired, but yet on the surface to see only what is required at that particular stage of production. With a floating interface, this will allow for tailoring to any department in a simple yet productive manner.
So again, kind of the same two sides of the coin. A standard input, both in terms of file type and in terms of the metadata and the way that that file and models are authored, as well as a platform that can then easily, from the perspective of the end user at least, rip that data apart and get it to the right people, allowing everyone visibility, but not at the cost of complexity or user unfriendliness. Fair summary?
Yeah. Yes, and that includes everything: workflows, checks, reviews, submittal transfers, process integration. They all need to be, the system needs to see all of them as blockchain sets of data so that it can be floating and that the interface by which the users act with the data is totally customizable.
So a sole source of truth and essentially a constant understanding of how that source of truth is changing.
Yes.
Okay. So we've about run out the clock. Any final thoughts?
There's a lot to be desired, but for my final thoughts, we should push to get standardized file types done by yesterday.
Okay, I will feed that back to our management folks as well. So Paul, thank you so much for the time and the insight today. We look forward to talking with you more about this in the future.
Thanks a million. I appreciate the opportunity to give my input.
From conversations with Paul and many others, a unified digital workflow for managing fabrication and erection, all the downstream processes after engineering and detailing, is something of a holy grail for a lot of precasters. A workflow like this has the potential to transform the industry. It would solve a ton of the cost and logistics pressures that the precast producers face today, but it is difficult to get it right. It's a big change in the way we do business. It requires cultural shifts, and especially it requires better tools at our disposal. The way we work today, it causes us to lose insight, to lose information, to lose background, to lose data at every handoff, from the engineer to the detailer, from the detailer to the folks who run fabrication, from the people who are fabricating through to the erectors. An information-rich model can change that. It makes it possible to retain that information and access it, to quickly get it to those who need it, to have them consume that data and then be able to update the data as they go, to make it so that this data can be sorted and read by machine, not just by human. But the biggest obstacle we face right now is, well, what model? A workflow like this needs compatible data from engineering and detailing processes. To get there, we need BIM-based workflows for engineering and for detailing. That means stepping out of generic tools like Revit and stepping into specialized, focused precast detailing tools to take that Revit EOR model, to take the EOR model we have and add in detail and reach a finished, detailed model complete with shop tickets. So, with that said, let's look at exactly how we can start authoring a model like that right now. Frank?
Thank you, David. All right, so here's the project we're going to be looking at today. It's a simple parking structure with an attached office. We're going to work on placing columns, beams, double T's, and walls in our garage here, and we'll focus on, in a later webinar, stair towers, slopes, and slender walls in the interior. All right, so now I'm loading up an empty project, except for the things that I mentioned we're going to focus on later. I'm going to begin by going to my library and pulling a column element from there. I'm going to place this in my drawing in 2D. Notice that all the work I'm doing is in our 2D areas here in the gray, and all the result is coming out in 3D for us. This is one of our apps. If you double click on it, you can see it's like all the other columns that I'm about to place. It's parametrically driven. We'll add reinforcement and inserts later. But a corner column, same as a side column, it just has more corbels turned on. You can see I can adjust the level, the top level of each corbel. All that geometry can be controlled parametrically and saved into your library for convenient use. Next,
These
David.
apps are a Python-based tool that we develop to automate and speed workflows. Anyone can develop them. We have contract developers. We've also taught a number of our users to develop them on their own.
All right, notice how when I place library elements, I'm able to apply a final rotation. I'm able to place multiple quite easy. Once I have a single column down, if I need more instances, it's just like any other CAD block that you would use. You're easily able to copy it over. Now I'm going to do a simple polar array. Since our building here is a rectangle, I can do that. And now I'm going to do a quick rearrangement of the mark numbers just to find all those identical shapes inside of our model here. We can see our 2s, our 3s, our 1s, everything's lining up just like we wanted to.
This is an important theme going forward. We have all the simplicity of CAD, all the intelligence of BIM.
All right. Now I'm going to create some space here in my model. I'm going to create a submodel for each of my individual column marks. So now that I have that, I can actually right-click on my element, and I can go to the detail drawing file, we call it. This, like I said, is just a simple submodel where we can do all of our self-contained work to a single element and have that work transfer over to the other elements in the model. So again, here, just going to use my app, and I'm going to turn on my reinforcement and turn on some lifting inserts. You can see we can do edge lifters, top lifters, the reinforcement, we can control this in the different zones. We have different styles about how it's all placed inside of here. If I need to change anything, again, it's just parametrically driven, real simple for you to do. All right, now that I have some items in here, I'm going to associate these with my column. And we'll create a shop ticket for this. So we can see what comes out of the automated workflow. It's automatically going to dimension any bars that you placed in here. I can continue to work in here if I need to place additional bars. It's as simple as using my regular bar shape tools, of which we have many, for all the common types, open, closed stirrups, freeform bars, what have you. Now it's just as simple as choosing what I want to place. I can do an expand and adapt to edges. If I want to place a stirrup in here, it's as easy as drawing it, just like I would in any side of any other view or section inside of ALLPLAN or plan bar. All right, so now once I have the model populated with reinforcement and inserts, I'm going to copy this over to the rest of my model. And it's just as simple as selecting it, and it's going to send that back. ALLPLAN plan bar is very quick with even a lot of details in your model. But if you have somebody working on a slower, older computer, this is nice just to keep everything separated so it doesn't slow down maybe some of those older machines. But like I said, it's very quick. So rendering all of these bars inside of your model is not a problem at all for us.
And this synchronization function really shows off one of the ways in which this is intended to serve the precast market. I can control an entire mark number from one location.
Now that we've completed our columns, we're going to start placing our walls. For this, we're going to use our profile wall. It's as simple as selecting a profile, choosing the height. Notice that we're going to attach it to our floor model here. These drawing files are attached to the floor model, so they know exactly what level things should be placed at when you're placing it in a specific drawing file. Later on, when we copy these to another drawing file, you'll see it automatically adjust the level for us. All right, so I'll draw my first wall over to from one column all the way to the end here. And now we need to notch out around our columns. So for that, we're going to use a niche. This again is parametric. I enter the width, the depth, the height, so on. And then it's just a matter of selecting it in my 2D model. Again, with the joint, it's parametric. You select right in your drawing where you want to place it. You confirm some parameters like the width of the joint, the position of the joint, and it will hold back that opening for you.
And even though all of these things are parametric, there's nothing in here that doesn't look exactly like doing it in CAD.
Exactly. Notice all the work that I'm doing is in 2D. Even here, when I come and I use my simple stretch command on the wall, if I want to take this back to the edge of the column here, and then I can even do a continued delta offset of X offset of 3/4 of an inch. So now we got that joint. And finally, we'll place one more niche to block out around the column. Now that we have our spandrel done, we're going to place our basic wall. This is just a simple 8-inch by 8-foot wall. And again, we're just going to draw from one column all the way over to our other column. No niches are required here, but we do have to create joints at all the columns. ALLPLAN does have an automatic division creation tool for your wall elements. This is great when you have a long panel or a long series of panels that are controlled by the maximum width of the beds. Here, though, where we have smaller walls that are controlled by the column locations, it's easier to place those joints correctly or manually, individually. Now I'm going to do a copy and rotate or a polar array to bring these around to the other side of my rectangular building. And now I'm going to complete out this first floor with my beam. As before, I select a profile, a height, and it's just as simple as coming down to my column. I'm going to create a 3/4 inch joint, draw from one column to the other, and again, do a 3/4 inch joint. Now it's just like any other CAD operation. I can use my copy routine, copy it down to my other beam line, and finally, I'll use a mirror since they are symmetric to bring it over to the other side here. Now that we have slab level 1 complete, we'll go over to our slab level 2 drawing, which has different planes assigned to it from the floor model. And now I can simply copy and paste into that other drawing file, and it'll move it up to the next floor for us. We'll do this one more time for the third slab level. And we've completed the basic shape of our spandrels, our walls, and our beams. Now I'm going to use my object browser just to hide my beams, and I'm going to create some precast elements out of these walls. This essentially just assigns some material properties, you know, how does it want to be marked, what kind of mark numbers does it get, just basic attribute data. Again, this is all stored from your library. It's very basic information that you configure early on, and then it's just about using those from your library in each subsequent project. All right, now I've created my individual walls. We can see that they're marked. Looks like it's automatically found all the identical shapes and size members and then marked them, the identical ones accordingly. Now I'll go ahead and break this off into a submodel as we did for the columns. Now for the beams, we'll create elements out of those. Simple as selecting the type of element it is to be, in this case a beam. Select the objects. First I need to convert them.
And the change management ability here is just incredible compared to a platform that isn't focused in this way. Because I can go into one place and manage every identical object, I have the ability to make sure that they're all updated properly at every stage. And there's a lot that we can do with that data downstream. A downstream workflow is by no means limited to, I'm going to finish this model, I'm going to finish these shop tickets, and then I'll provide that information to the fabricator. We can kick over a preliminary model at any stage. So even right now, we could read concrete quantities out of this model.
All right, so now I've just come over to my submodel where I'm looking at my individual detailed element here. I've added some reinforcement, some inserts, again, just using our parametric parts here. You can see that you can edit the stem pattern, you can edit the strand pattern, the legs or the stirrups inside of the ledges. You can choose if you want to combine those or keep them as separate elements. So it's extremely configurable. Notice that I'm able to pull it right out of my library, use it over and over, and share this even at office. It's a lot of inputs, but you can save all this stuff at a project level, at a private level, at an office level. So only one person has to be smart one time, and then everybody can benefit from that work. All right, so now I'm going to associate those elements with my model here and create a drawing for this element. I can choose from many layouts. You can have them stored for all the different type of objects and then the different scenarios that you may have here. So this one's better suited for a horizontal panel. You can see it brings in some very basic stuff. In a later video, we'll cover how to add automatic details as well. But here's for the basic outline. Here's for the reinforcement. You can see it's generating those schedules, automatically attaching it to it. It's generating bill of materials for us. It's automatically dimensioning where the inserts are, where the reinforcement zones start and stop. So all this is done out of the box for you, and this is still, a full CAD program. So at the end of the day, you can come in here and draw, cut fresh sections, do whatever you need to enhance this in any way that you want.
And Frank is calling this very basic, but the reality is a single shop ticket like that represents a pretty considerable investment of time. Whereas here we have the automatic tools to detail the building in 3D quickly, and the shop tickets are coming for free.
That's a good point. I say basic, but it is very automated. It covers a lot of situations. It's robust is maybe a better word. So that same tool that I used on the spandrels, you can see here it's again used on the inverted T-beams, just entering a whole bunch of different parameters, and now it's adapting to the specific shape and size of this object that we have.
I think you've been using this for too long. You've forgotten what it's like to do some of these things in CAD, Frank. I should have had you on a timer for this, frankly. It's only been, what, 15 minutes since we started?
Right, and we already have a significant portion of our most common members done. You can see the shop tickets are already at a very high level of detail, ready for, maybe even submittals, something that requires a low level detail. You already have that, and any changes are instant too. So the stuff you see coming out of this is as quick as it is to do it the first time. It's even quicker to do it a second time or a third time when changes do occur. All right, so.
And absolutely, it's worth noting that the appearance of the shop tickets is hugely customizable. They can be used for everything from complex architectural wall panels with brick overlays to the simplest double T's. and everything about them can be changed. The exact appearance of the drawings, fonts, line weights, dimensions.
Right, and you'll notice here that as I worked, I changed those spandrels. Now we can see that reinforcement's been populated into the model. Notice how quick this is, maybe even through the webinar. You can see it's very responsive, no lag at all. All right, so now that we've created some basic shapes, now we're going to do something a little more complex, our double T's, and we're actually going to do this even with the drainage. So let me go ahead and make everything else in a reference state so that we can't touch it. We can see it, we can snap to it, but we're not going to accidentally grab it or make any changes to it. All right, so now I'm going to start my double T tool, but before I do that, I'm just going to open up a quick couple of viewports. I have 5 points that I have to put down, and this just makes it easier for me to click. So I'm going to start my first point here, and then just run over to 5 points. Each of these points is, where I can specify an exact elevation for this double T at the end. So on the one side where I have my drop corner, I'm going to drop it here in the middle. I need 5 points. Over here on the end where I'm not, I'm just going to do a couple of points, and that will be sufficient. Once I've given it the 2 lines for each end of my beam, you can see that it's going to place out that whole span for that entire bay here. Notice that I didn't plan out this garage. Well, I planned it out this way so that we could see what you might need to do in some cases. We have an extra couple feet that we need to compensate for. So I'm actually going to take this placement. Right now it's all one placement. I'm going to say split the placing region at this corner, and then use this joint to define where I want the beams to end. And I'll say just go ahead and adjust it on both sides. And now we'll cut those beams back. Right now they're 10 foot, and it's going to take them down to an 8 foot. So I took, 3 10-foot beams, turned them to 4 8-foot beams, and that gave me an extra couple of feet there that I needed. Now I'm going to drop or lower one edge of it just by a foot and 1 inch. And so what that is over here where we have the slope for drainage, it's going to lower all those T's and actually kind of rack them or warp them, as we say, down to this. This is going to represent the warp shape. In a few minutes, we'll convert them back to an unwarped state so that we can create our shop tickets and our reinforcement inside of them.
And the conversion between warped and unwarped, of course, does all the math to determine exactly how much longer these need to be to rest properly on their bearings on the corbels than they would if they were not warped at all.
That's right. And I just kind of flipped through some of the options there, but you can see it's automatically placing end connectors, panel to panel connectors. If I look in my side view here, we should be able to see at the DAPs where I can enter what those should be. I can also place fixtures or inserts where those DAPs go for extra reinforcement. All right, so now that I have the basic shape of it, the warp state with all of the inserts inside of it, now I'm going to create an unwarp state, populate it with reinforcement, and then create shop tickets from those automatically. All right, so I'll start my double T reinforcement tool. It's as simple as selecting exactly what kinds of reinforcement you want to see in here. I can actually put down a little preview guy for us to see. So I see I have my bars in the slab, bars in the stem. I can use meshes. I can set all the stuff again parametrically, a lot of inputs, but it's going to create exactly the reinforcement that you need inside of this beam. You can even do additional reinforcement for your adapt ends if you'd like. All right. Now I'm just going to select all of these beams and then ask ALLPLAN to go ahead and create all the unwarped states and the reinforcement. It's going to take a little bit, but it's doing a lot of effort for us right now.
And of course, once we've gone in and created all this reinforcement in mass, we know that in some instances, something about it's not going to be accurate. There may be an opening somewhere that isn't accounted for. You still, as the end user, have the ability, when there it is before I even finished half of what I wanted to say. But you as the end user have the ability to go back in and make any change you want and have it reflect across all or any one of these elements. So if I need to open something up for utility conduits somewhere, and I need to have the mesh be opened up around it and maintain clear cover, I can do that without affecting the other elements, and it will create me a separate mark number, a separate shop ticket, a separate bill of materials.
That's right. And you'll notice I was going around in the 3D just to highlight the point that these are now unwarped. So it's taken those, it's unwarped them, made it a flat shape, which it will be in until you place it on its bearings, and then it actually, you know, rests or settles into position there. All right, so now that I have that, I'm going to create a layout for it. Again, just selecting a template. And here we can see the reinforcement. Oops. I'm gonna bring that back. There we go. So we can see that it's, again, just getting all those dimensions for us, creating quick views, schedules, list of fixtures. All of these are automatically created for you. And any changes you make, you can do these right inside of the shop tickets. So before I was talking about adding reinforcement, but if you also want to grab the fixture and adjust that, you can. If you need to make multiple copies of it, it will update the quantities. And here you can see that it's automatically updating these dimensions for us. And all of this stuff is, again, stored in catalogs. So each of my connectors, I can give it a specific name, how it should be labeled in the dimensions. I can give it a specific name, how it should be labeled in the list of fixtures. All of that can be controlled independently and set to your specific company standards. We have a lot of stuff right out of the box too, so you can use those as templates when you are generating all those different parameters for your configuration. All right. So now looking back at the model, we can see just in a very short amount of time, very quick effort. Obviously, you didn't watch me enter every single parameter in, but that should give you a good idea of what it means to do parametric design, interactive design inside of PlanBar, and what it means to get some automated shop tickets out of those in a basic sense. All right, well, that completes my portion of the webinar. I'll hand it back to you, Dave.
And of course, I had myself on mute. There we go. Thank you, Frank. As you can see from Frank, just on the model authoring side, on the engineering and detailing side, there's an incredible amount of efficiency and flexibility that remains to be realized today compared to what's possible. And that's without even touching on the uses of this information downstream. We haven't really hit upon how this model can then feed into everything that Paul discussed earlier with us in the interview at the beginning. But the reality is this kind of data is what's necessary to really achieve an integrated digital workflow for operations, not just engineering, not just detailing, but for folks to leverage this information and use it to streamline and optimize what they do later on. A brief introduction of our company, because I know we're not yet a household name, but ALLPLAN and PlanBar are owned by the Nemetschek Group, which is a very large, well-renowned AEC software company. We invite you to take a look at the content that we have for precast markets online, do a little bit of research, come ask us any questions. At this point, I would like to wrap this up, and I'm going to turn it back over to Royce for a bit of Q&A. Thank you very much, everyone.
Thank you, David, Frank, and Paul. Now we have time for some questions, and we have a couple in already. The first question is, excuse me, can a production report be generated for any period of time during the production process?
I'll take that one, Royce. Can you hear me?
Yes, I can.
Okay, excellent. So yes, we can. What we can do with this model downstream of it once it gets into the operations management platform is actually manage either the entire model, segments of the model, or individual elements through an entire range of statuses. So throughout the production process, we're able to go in and understand what's going on with this element, digitize all the information related to it, and link that to the element from purchasing straight through to shipping it out on an A-frame on a truck.
Okay. Next question is, how does your licensing work? Can you have multiple computers access one license?
Yes, for the platform that Frank was just using, we can have either individual user licenses or what we call network licenses that can be shared among multiple people.
Question just came in. Is this software applicable to precast members that have curve?
Yes, absolutely. We can handle curved members just as well as we can handle rectangular members. We have a lot of tools specific to that, not just for modeling, but for reinforcement as well, for sweeping bars along path and all kinds of unique original shapes.
Okay. Next question is, it looked like warping the DTs made those mark numbers unique. Is that correct?
That's right. Every precast element inside of Plan Bar is automatically marked according to rule set that you get to configure. You can set the prefixes, suffixes. You can rearrange mark numbers. It looks for identical ones within a tolerance and combines those up as well. So they're unique for unique members.
Okay. This is a two-part question. How easily does the BIM model merge with models from other programs? And are there extra steps needed to have models merge correctly?
We import and export many different file types. So any 2D, 3D data that you want to get into or out of ALLPLAN, you absolutely can. IFC is the go-to standard. It's a common data environment for all platforms, all of the softwares, and it's meant to be merged with other models.
All right. Next question is, can you do batch shop drawings?
Yes, that process is similar to what we saw, but for the individual, you choose the same tool, but in a batch mode operation. You choose which kind of layout template should be applied to the individual member types, and it will create all those and print them to PDF or whatever file type you specify.
All right. We have one more question. Can you send the model directly to our laser plotters?
Yes, we can drive laser plotters using the operations management suite. So instead of using shop tickets or alongside shop tickets, we can also project images.
Okay, well, it looks like that's all the questions we have. So on behalf of PCI, I'd like to thank David, Frank, and Paul for the great presentation, and all attendees for your participation. There will be a pop-up survey after this program ends. If you have any further questions about today's webinar, please email marketing@pci.org with the title Digital Precast Webinar, and we'll make sure to forward those to our presenters today. Thank you again. Have a great day, and please stay safe.